What is up, guys? My name is Sam, and today we're going to be talking about an introduction to smart contract development using CC tools for Hyperledger Fabric. This video assumes that you know a little bit about blockchain concepts and smart contracts, but also is aimed at beginners that want to make concrete things using Hyperledger Fabric. I'll be leaving timestamps in the description so you can skip through the video if you like. So as I said, we are focusing here on the Hyperledger Fabric platform, which is an open source platform from the Linux Foundation with a thriving community which GoLedger is proudly a member of. If you want to learn more about Fabric, I highly recommend checking out the documentation and exploring. And let us know here in the comment section if you have any questions about Fabric that we can help you with. Anyway, let's go on to the video. So what is a smart contract? A smart contract is essentially a piece of code that runs according to well-defined rules and achieves the same output for a set of inputs. This has been well explained by Nick Szabo, who proposed the concept and coined the term. Take, for example, a vending machine. It takes a certain set of inputs, a quantity of money, and which product you want to buy, and returns the product that you bought. It has well-defined rules, and given the same world state and inputs, it always returns the same output. In Hyperledger Fabric, we call those smart contracts chaincodes, and they can be written in Go, Node.js, and Java at the moment. And how are chain codes built in Hyperledger Fabric? In Fabric, a chain code must implement a so-called chain code interface. That means that it must implement two methods. One is the init method, which is called whenever the chain code is instantiated or upgraded in the network. And the other one is the invoke method, called whenever someone invokes a transaction. However, how you structure your chain code is up to you. That gives you room for you to develop freely. To interact with the ledger, we use a chain code stub interface, which is a link between the chain code and the stored data on the ledger. Is the link that allows you to interact with it. The Fabric team has since wrapped these requirements into a package called Contract API for ease of use, and you can check the repo linked in the description. But anyway, let's take a look at an example. I'm moving here to my computer. Okay, guys. So this is the FabCar example chain code. It is available from the Fabric samples repository. And here we have the source code for this chain code. This chain code is written all in one code. We'll be taking a look at the Go version of this chain code. And here we can see our Go code. This chain code essentially takes a structure representing a car and registers it in the blockchain. As I said, a chain code must implement a chain code interface. So that means an init function and an invoke function. Here we can see our init function right here. And this init function does nothing. It may be useful in some cases, so you can init a state in the ledger. Here it actually tells you that the best practice is to have ledger initialization in a separate function. So here the developer chose to use an init ledger method. Okay, so this is the first function we have to implement. The second function we have to implement is the invoke function. So we get our chain code stub interface with an object called API stub in this case. And here we can get our functions and parameters. So this is what is actually sent by the person that is transacting with the arguments of the transaction. One of those arguments is the function that the transaction is going to call. So here we have an if-else structure to actually select the function we are going to call. So if the function is query car, we call query car. If the function is create car, we call create car, and so it goes. Anyway, So this is pretty much everything that chain code needs, init and invoke. We could, although it's not a best practice, code the transaction itself right here, in between the ifs and else's. But this is not a best practice. So anyway, uh, here we can see a type car structure which lists all of the properties that this car has. For example, the maker, model, color, and owner. Uh, and here we can see the transaction for registering it. So this create card transaction. So it takes 5 arguments, which is validated in this case by seeing the length of those arguments. The args variable here is a string slice. It assumes that all of the args are in the correct order and just creates a new variable using that structure that we saw above. And then it marshals this structure. It marshals this structure, and this turns into a JSON. And then it uses the first argument and the car as bytes, which is the JSON, and calls this function put state, which effectively registers it in the ledger. And that's it. That's the create car function. This is an example, obviously, and we can see that it assumes that all of these R's are correct in the correct order. It doesn't validate any of these, just the quantity. And we can make this better. We can honestly make this better in a production chain code, and that's what we're going to do. But first, let's say you wanted to take this smart contract and test it. If you took a look at the tutorials that the Hyperledger Fabric documentation offers, you'll probably already tried the test network tutorial, and you probably toyed a little bit with a code similar to this one. But first, you had to actually get your test network up and running. The scripts are provided in the Fabric samples repository, and this is easy enough for development. But then you needed to install and instantiate your chain code, and you probably made some changes to your code. You had to upgrade it. We created CC tools to make developing chain codes easier in pretty much every way. It's a solution that is used every day at GoLedger, and it is used by our customers in production. So let's take a look at what CC Tools has to offer. So here I have our repository of CC Tools. I'm not going to go deep in this code right now. That will be in another video. But what is the CC Tools library? GoLedger CC Tools is an open source project led by the awesome team we have at GoLedger. And it's open for anyone looking to develop chain codes in Go. And what does it do? It implements types and methods that accelerate development enormously. It provides a structure for defining assets, asset types, transactions, data types, validations on asset fields, asset referencing, ledger operations, and it comes with a local testing network with API interaction, so you can develop with legacy systems or a front-end interface in mind. And all of the features of CC Tools are going to be listed in this description. CC Tools also has a read the docs page. We are constantly updating it. Here you can find some tutorials and links to our Discord, so you can chat with us and ask us questions about CC Tools. But anyway, it's what they say, show, don't tell. So here I have our CC Tools demo repository open. This repo is a basic example of an implementation using CC Tools. It's a public GitHub template to provide developers an initial structure of a working project with all those artifacts available. So anyway, here I have my folder cloned and opening VS Code. So let's check our structure. Here we have this folder structure. We have the chain code folder. We have Fabric and Fabric 2, REST server, and test. And we have a bunch of scripts right here. So let's dive into the chaincode folder, which is the object of this video. Here in the chaincode folder, we have our Go code. So we have our main, and notice that in our main we have the init function and the invoke function, implementing the chaincode interface that is needed for a Fabric chaincode. And here we have three folders that are pretty interesting. We have an asset types folder, and here we have definition of assets. So for example, here I have this person asset. If we compare it to the FabCar chaincode, this is where I would declare my car asset, like FabCar did. So FabCard just used a Go struct, a native Go struct. Here we have an object. We have an asset type struct, and that takes all of these elements. So we have a tag, we have a label, we have a description, and we have the properties. So for example, this is a asset prop slice, and here we can say what our props are. So I can say that my prop has a tag of ID, I want it to be a key, it is a required property, and the data type is actually a CPF, which is which is a type of social security number in Brazil. So we can actually create this data type and validate the input of this property against the data type that we declared. And this is declared in another folder. We'll be checking it out soon. And we can actually say what are the writers of this property. So if I have a writers defined in a key property, this means that only this organization can toy with this asset, can create it. Here I have another property, and I can add a validate function to it, so it can be validated before entering any transaction at all. And I can have a date of birth, and which is a date time, and height, which is a number. And this is how I can create new assets for my chaincode. Here we have another asset that is a library asset with a library name, with a book collection, and this is where it gets interesting. I can reference other assets. So for example, here I have a book reference slice, so it's a list of references of books, which is another asset. Book is another asset, and the book has a reference to the current tenant of this book, which is a reference to a person asset. So you can see that we can create and link these assets pretty easily, making this data mapping. So as I said, we have the data types also. We have some primitive data types that includes strings, numbers, date times, and booleans. But also you can create any data type that you want. So for example, here we have a data type that represents a CPF. A data type is pretty much a parse function that will validate this data type against what you want. And this data type takes a CPF in a string format and validates it according to the rule of formation of a CPF, and then it returns the CPF so it can be used inside the transaction. Okay, so I'm editing this video and I forgot to say that every asset inside CC Tools comes with a set of transactions built in. Those transactions are create, read, update, and delete asset. So that's why moving forward, I was able to create assets without using the transactions that were defined in the TXDevs folder. So, okay, back to the video. In the TXDevs folder, we have our definitions of transactions. So here we have, for example, a transaction that is called a create new library. which is kind of obvious. It's going to create a new library asset. So it receives pretty much the name of the library. And it's also worth mentioning that this is also a type, a structured transaction. Um, and it has all these properties. It has a tag, it has a label, description, method, colors, anyway, and obviously the arguments that it receives, and a routine, which is a function. And this is where you code your transaction. We so here we have our library name, and then we create a library map, and we fill the contents of this map. And now CC Tools helps us turn this map into an asset, and this asset types comes with a method, so you can register it in the blockchain. This method is called putNew, and once you do this, CC Tools takes care of validating this asset and calling the put state function that is implemented by the chaincode stub interface. And once this is done, our library is registered. So it's pretty easy to use. Here we have a update tenant for a book. So we receive a book reference and a person reference. We take the book that exists on the ledger, and we take the tenant that also exists on the ledger. Then we take the book map and we update it with the new tenant of the book, and then we call the update method for the book asset. This hands over the update functionality to CC Tools, and CC Tools takes care of the rest, making all the validations according to what is defined. Also, this template, it comes with, as I said, a bunch of scripts, and these scripts actually make a test network locally on your computer. You just have to have Docker installed, and you can take startDev.sh and run it. This will bring up everything that your network needs to work and instantiate your chain code. Here we have startDev and startDev2. And startDev2 is the script that supports Hyperledger 2.0. And we have both of these options available. We are still working with some networks in 1.4, and we are migrating a bunch of networks to 2.0. So it's good to have two test networks, so you can ensure that your chain code is working, both of them. So right now I'm deploying one of those networks. I just created the channel, and it's going to join my peers. It's going to install and instantiate my chain code. And why is it important for you to test your chain code with Hyperledger 1 and Hyperledger 2? One of these days I was trying to use a Go library that that only supported Go from 1.16 and above. And turns out that the peer uses a build environment that uses Go 1.13. So this library could not be used in my chain code because the peer was building using another version of Go. So right now the script is creating the API part, the CC API, chain code API, and it's going to deploy 3 APIs for us, one for each organization. Right now I have 3 organizations, and once these APIs are available, we will be able to transact. Another nice feature that our repo allows is a web interface. So you don't have to assemble requests to send to the API. So we can run this script, run cc web. It's going to download an image and deploy an interface in one of the ports locally on my machine, and you'll be able to see what I can do with it. So okay, so it is running. I'm going to open my my browser and head to localhost 8080. So this interface will load up all of the asset definitions and all the transactions definitions. And I know it's not the most beautiful thing, but it's very useful when you're developing. So you can open this network, connect to one of the APIs, and then you can head into this little sandwich bar, and here we can see all of our assets. So for example, we have the assets that I can read and write. In this case, it's library, and we have assets which are read only. Why is that? Because I defined it like this in my chain code. So for example, right here in my asset definitions, I told that only arg2 can write to book, only arg3 can write to library, and only arg1 can write to person. So in this case, I am arg3, and I can write to library. So let's do that. I'm going to create a new asset, and I can just provide a name, my library, and I don't have to set a book collection. It's not mandatory property, and I don't have any books right now, so I don't have to. But one thing that is interesting, I can click this curl button, and I can see the curl request that I have to do for the API. So in this case, I could copy this and paste it in the terminal and execute the transaction like this, or paste it in Postman, for example, and assemble my request like this. So I click submit. It's going to take a little while, and library created successfully. As I said, I'm on arg3 right now, so let's change it. To change it, I can click on this little gear, and I can type whichever node I have. So if you check your Docker containers, just type Docker PS. You can check the ports that the APIs are running from. And right now we have the APIs running from port 80, port 980, and 1080. So right now I'm connected to 1080, but let's connect to 80. And it's gonna load up the interface from the point of view of the first organization. So right now you can see here I am on organization 1, and I can write on the asset person. But let's check first the library asset. So here is my library that I just created on organization 3. I can check the history of this, and I can see that there's only one registration for this asset, and I can see the timestamp, and I can see the organization that did this transaction. But now let's just head into the person asset and create a person. So here I can create a person. I have to use a valid CPF. I'll try to use one that is not valid so you can see our validation working. And let's say that I was born on 28th of April 1997, and my height is 167. I'll create this, and probably we're going to get an error because we are validating the CPFs. So okay, so right now we can see that we couldn't write this asset because invalid argument, fail constructing asset, fail to generate key for asset property. CPF must have 11 digits. So I'm going to add a real CPF here. So let's grab a CPF generator and just put this instead. So let me fill it real quick. Okay, so right now it created person successfully, and I can check that right now I am registered as a person here. And this is just a tiny little bit of what CC Tools can do. We are planning a bunch of videos showing you uh, how to implement specific things using CC Tools. The next video I'll make will be probably an implementation of a ERC20 token. So if you are interested in tokens, please subscribe to the channel and don't miss our tutorial implementing one of those tokens using CC Tools. Also, I'll leave in the description our Discord server so you can interact with us and ask us questions. If you have any doubts, please put it in the comment section and we will answer all of them. And that's it. I thank you all for watching and please stay tuned for the next video. Peace.